Okay, this will be lesson number 4 for grade 12 math, the statistics unit. Alright, the recording appears to be functioning normally, so we will be getting started here. This is lesson 4 in your package, advantages and disadvantages of using different measures of central tendency. Today's lesson will also be followed by the next hand-in assignment. So there's a variety of reasons why we use the different measures of central tendency. Let's first of all give you a refresher on what those are. So first of all, the various measures of central tendency. The ones that we've covered in this unit: the mean, the mode, the median, and then the two most recent ones, the trimmed mean and the weighted mean. Trimmed mean and weighted mean. Mean is the average, add all the numbers together to divide by the number of numbers. Mode, of course, the number that occurs most often. Median is your middle, once you put them in order. Trimmed mean is where there's outliers and you took away some of the outliers and then calculated a new mean, either very low or very high values. Weighted mean is where you give more value to certain parts of your data, such as in a math course, if you give more value to the exam or to a major project. The weighted mean. All right. So let's look at, they've got a nice example right on page 49. Let's take a look at that, and then we'll continue from there. The golf scores of the first 9 holes for Tom and Sam are shown below. So they've both got a total of 45. It's looking like they're pretty similar in how they play golf and what their scores are. It's looking identical, until you see that Tom has an outlier of 15, where he probably did something that he doesn't usually do. Based on all his other scores, 3, 4s, and 5s, that 15 is probably some kind of an exception. Who knows what it might be? I don't even play golf, so I don't know. But the point is, if you were to look at this, the average is not the best way to compare Tom and Sam's golf score in this case. The mean isn't very good because of the outlier here. So maybe you could use a trimmed mean and would give you a better idea actually. Like if these guys were playing head to head and you said, okay, we expect the score to be tied because we're looking at a 45 for each of them here. That's most likely not going to be accurate, because what are the chances that Tom is going to use 15 shots on one hole again? Very unlikely. Probably something happened or he really messed up, Is that going to happen again? Probably not. So that's the point, is that sometimes measures of central tendency don't always show exactly what we need them to show, regardless of which ones we use. They always have their advantages and their disadvantages. The median here might be better. Well, put everything in order and then take the median score for both of them. That might give you a more accurate reflection. Let's very quickly do that. 3, 3, 3. He has 3 3s. Then he has 3 4s. And a 5 and a 15. Did I miss something here? He has 4 4s. Squeeze one in here. Okay. Now, looking at this guy's scores, his lowest is a 4. And he has a couple of 4s. Four 5s. That's 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 5s. 6, 6, 5. So your median here for Sam is 5, and your median for Tom is 4. So right away, you no longer have an identical score when you look at it that way. Whereas if you look at their averages, 45 divide by 9, by 9 holes, you're going to get a 5. So it looks like on their average, they both have a score of 5. If you look at the median, you see Tom has a 4, Sam has a 5. And if we were to do a trend mean, that would give us a different result again. So that's the point, is that measures of central tendency, you have to try and use them in such a way that they're giving you an accurate representation. And if you don't, your data might not be as accurate as you need or want it to be. So we're going to continue on page 50. Just going to give an overview of pages 50 and 51, and they review the advantages and disadvantages of the measures of central tendency. The mean, we already know what the mean is. It's useful if the data has no outliers. If you have no extremely high or low points, the mean is good. Disadvantages, it often doesn't give you what's typical. What it doesn't getting the average of something doesn't always tell you what usually happens. Like if you had a set of data with a bunch of 5s, your mode would be 5, and you figured out the average and you got an average of 6. Is that really giving you, or what's going to happen most of the time is to get a 6? No, more than likely it'll be a 5. So the mean doesn't always represent the typical outcome, and it can be affected by outliers. But if you don't have outliers, the mean is pretty good. The mode, its advantages, extremely high or extremely low values don't affect it. It's not affected by outliers because outliers are very rarely going to be the mode. You're going to have the numbers somewhere in the middle that are the mode, whether you're looking at pairs of pants or numbers of sheep or whatever, number of lambs, whatever you're looking at, whatever the mode is, it's not going to be an outlier. So mode is not affected by outliers, or very rarely. The mode is the item that appears most often, which is good if you're trying to keep track of something. They're giving baby names or video games or votes during an election, like which candidate got the most votes in an election. That's the mode. So if you're tracking something where you want to know how much there was of a specific thing, which there's a lot of cases like that, then you would use the mode. And probably the biggest advantage of the mode is it's quick and easy to find. There's not much point in looking at an average when you're counting votes for an election. You're going to look for the mode. Disadvantages? It could be very far from the middle, and then it might be an inaccurate representation. So if you have a whole bunch of data that are far away from the middle, and that becomes your mode, like if you had a whole bunch of 2s, but your average is really about a 10, something like that. And of course, if nothing appears more than once, you don't even have a mode. So that's the mode. Let's go over to page 51 and look at the median. Recall that the median is the middle value of a data set when the values are written in numerical order. So the middle. What are the advantages? It's useful. It'll often give you what's typical. The mean doesn't always give you what's typical, but if you look at what's in the middle, you're probably going to be looking at what usually happens. And the median takes care of outliers because they're all the way down at the end and you're looking at the middle. Whereas when you're doing the average, that doesn't quite cut it. Okay? Disadvantages: time consuming to arrange all the numbers in a data set. I don't know how much of a disadvantage that is because you have to add them all up to find the mean. I don't see that as a big disadvantage. If the gap between values is very large or very small, the median can be inaccurate. So if you have a broad range of data, let's say you're going from 1 to 1 million, then maybe the number that's in the middle might not be very good. Let's say you have a lot of numbers that are between 1 and 300,000. Then all the rest of your numbers, the other half of your numbers, are between 400,000 and 1 million. But your median is 300,000 in that case. So large groups of data can be a problem when it comes to the median. That's one of its big disadvantages, is that middle number, large numbers or large data sets, that middle number is not always a good reflection. But of course, your biggest advantage with the median is that it doesn't need to be concerned with outliers. Okay. Page 53. The trimmed mean, which was our last concept. You get that by calculating the lowest 5% and the highest 5% of your data values. And that usually eliminates the outliers. It's resistant to outliers. It's useful for data with skewed values, in other words, data that's all over the place. The trimmed mean gives a reasonable estimate of the center of the data. So the trimmed mean is somewhat like the median. That's the good thing about it. Disadvantage: if there are a significant number of outliers, such as more than 5% in a given direction, the calculation of the trimmed mean may still include outliers. So if you have more outliers, the trimmed mean might not eliminate all of them. The weighted mean. And again, this is where you put more emphasis on a certain thing. Advantages. It is useful when individual data represents multiple people, such as everybody writing the same test. It is useful when a sample overrepresents or underrepresents certain parts of the population. So you can put more emphasis on things that are important. Like if you're a dentist and you're tracking cavities and root canals, maybe one is more important to you than the other because maybe root canals make you more money. Just an example. It is useful when some values in your data are less accurate. So the data that you collected might not always be as accurate, so you can put maybe more emphasis on the data that you know is accurate. Disadvantages of the weighted mean: it can be biased if arbitrary weights are given to the data. Like if I was to say at the end of the math course, the brain power test we're going to be writing, that's going to be 90% of your final mark. Okay? So then, just give you a really quick example. Let's say one of you had 88% going into that final test that we're going to have. And I said that final test was going to be worth 90% of your final mark. And you were having a bad day and you bombed this thing. You got 55%. Well, this is worth 90% of your final mark, 0.90, and the rest of the course is worth 0.10. So then, if I do 88 times 0.10, I get 8.8. And if I do 55 times 0.9, which is 90%, I get 49.5. You would wind up with a final math mark of 58.3. 58.3. Even though you had an 88 going into that last test, an unfair weighting. I have taken courses where the final test was worth 50%. That was a lot of pressure. If you bomb this test, you could fail the course. If you're having a bad day, or there's quite a bit of stuff that you still don't get, you know, it can happen. I don't think. So, a weighted mean, it can be a problem if there's too much weight put on one thing, such as here. Okay. Taking a look at, next we're going to do some brain power. So let's go to page 57. Evaluate 15 times 17 times 20. 5 times 17 times 20. No, it's not. It's the wrong sheet. There we go. So, brain power. Page 57. 1. 5 times 17 times 20. I'm going to eliminate the two big numbers first. 17 times 2 times 20. 17 times double 17 is 34, so that's 340. 340 times 5. 300 times 5 is 1500. And 40 times 520 is 200. Final answer? 500 at 200, 1,700. And I hope you didn't do this one with a calculator, Austin. Let's look at this one. You went to the grocery store to pick up a few items. The total came to $21.37. The cashier gave you $40. What should your change be? $40, take away $21.37. So it's obviously less than $20, right? Less than $20, and you're looking at the 37, so it'll be like, you could round this up to, round this down to 21, right? So what is 40 take away 21? That would be 19, right? So do this, 40 take away 21, 40 take away 20 is 20, oops, sorry, I'll go back up here. 40 take away $21.37. Round this down to 21. 40 take away 21 is 19. Then just take away the 37 cents from 100 to get 19 cents. Take away another 37 cents. It's going to be 18 point something, right? And what's 100 take away 37? 63. $18.63. Very useful to be able to do that kind of stuff in your head. How many days and 15 weeks? $15 times 7 equals 10 times 7 is 70, 5 times 7 is 35, 70 at 35, 105. 4. In the months of November, December, and January, it snowed 14 millimeters, 60 millimeters, and 76 millimeters respectively. What was the mean, is it's asking. 60 add 14 is 74, and then add the 76. 70 at 70 is 140. So the 6 and the 4, that makes 150. And 150 divided by 3 is exactly 50 millimeters. Here's another good example. Is 50 average really good here? You've got 1 month with a very high snowfall that's skewing the other 2 months. You only had 14 millimeters in November, yet you have a 50 average. So is the mean good here, or just something to think about? Complete the following pattern: 7, 14, 21, and 28. 2, you should recognize immediately this is counting by 7, 35, and 42. No? Those lovely pop-ups. That's brain power. Let's look at a couple of exercises. The first one is right here on page 57, so we'll begin there. So this is page 57, number 1. Let's have a look. Mark Fair received the following marks on 9 mathematics tests. This is marks. Calculate the median. How many marks are less than the median? How many greater? Calculate the mean. How many are less? How many are greater? Calculate the mode. And then find how many are less and how many are greater. And then decide which measure of central tendency you're going to use. So, page 57, number 1. Okay, I wish I could get rid of these pop-ups. Do something about that. So, 1A. Find the median. Let's put them in order. My lowest number is a 25. Second one is a 50, and then I've got a 68. He really bombed one of his tests, didn't he? 68. A couple of 71s. And then a 72 and a 74. And a couple of 80s. So 369, just want to check, 369, yep, good. So my median here, taking just the middle, there's an uneven number of numbers. So your median equals 71. And B is asking how many are less than the median? An equal number. 4 less than the median, 4 more than the median. And the next step, part C, is to find the mode. So let's take all these numbers and add them up. It comes to 591. Divide that by 9, and there's my mean. 65.66. So, in this case, how many numbers are less than the mean? 2. Two numbers less than the mean. Greater than 1, 2, 3, 4, 5, 6, 7. 7 numbers greater than the mean. E. So 2 numbers less, 7 numbers greater. E. Find the mode. The mode, there's 2 of them. There is 71 and there's 80. There's 2 modes in this one. Modes are 71 and 80. How many marks are less than? How many are more than? F. So for 71, three less, and 4 are more. And for 80, there aren't any that are more, but there's a whole bunch that are less. For 80, there are 7 that are less. Sorry about the scribbling here. Didn't realize that when I took the sheet. G. So think about it. Look at the mean, the median, and the mode. Which one would you pick? Which measure of central tendency would you pick to represent the data? A median of 71, a mean of 65.66, or a mode of either 71 or 80. If I had to pick just one, I kind of like to have all 3 of them. If I had to pick just one here, I'd pick the median. The mean is kind of close to the beginning of the data. The mode actually has outliers in this case, which is unusual for the mode. So I wouldn't pick the mode. I would say the median. Is best in this case. Because it allows for higher and lower values. It accommodates the various parts of the data set better than the mean does, and certainly better than the mode does. The mode puts too much emphasis on those 2 outliers. Okay? We're also going to be looking at, on page 58, number 2. And that's right here. Consider the golf scores of two players who play 9 holes of golf. Note that Ethan was stuck in a sand trap on the 9th hole. So you've got Ethan and Caden with a total of 3, 4, 5, 3, pretty consistent scores, except on the 9th hole, Ethan gets a 15. So for each of these guys, we want to do mean, median, and mode. And then in your opinion, which player has the better score per hole? And in your opinion, which measure of central tendency is the most appropriate? Now, so before we do that, let's find out what the measures of central tendency are. Beginning with Ethan. So let's make sure that we're labeling. This is page 58, number 2, A. So we're going to do Ethan first. 3, add 4, add 5. 3, 4. 3, 4, 4, 3, 4, 15. Get a total. Let's go. 12, 18, 22, 26, 29, 33, 43, 48. 48. Divide by 9. 5.33. But we're going to say 5 to make it easier on ourselves. We're going to say that his mean is 5. You're not going to have a third of a golf score, I would think. Median, 333. 444. This is, how many 4s have we got? Oh, we got another 4 here. Then we have a 5 and a 15. And so his median is a 4. Mode is obviously 4. So we should have labeled here, hey? Mean, median, mode. Okay. Second guy, mean, median, and mode. This shouldn't be B and C, this should be just A. So this is now B, the mean for the second player. 5, 5, 6, 4, 6, 4, 4, 5, 4. 10, 16, 20, 26, 30, 34, 39. Add 4 is 43. 43 divided by 9. 4.77. I think we will need to go with decimals after all. He has a 4.8 and we're going to say that he has a 5. Otherwise they'll have identical scores and they really don't. So we do need to go with decimals. He has a 5.3 and he has a 4.8. So, C. In your opinion, which player usually has the better score per hole? That would be Ethan. In spite of his score on the last hole, he messed up on the last hole. Ethan had a better score per hole until he reached hole number 9. Now that's this is my opinion based on looking at the data here. Maybe you have a different one. You think you want to count hole number 9 against him a little more and say, yeah, he's not that different per hole, because what good is it to have a really good game and then mess up at the end? It's like playing well in net for 57 minutes and letting in 3 soft goals in the last 3 minutes. What have you done? You've probably still lost the game, right? So, but that's up to you. You want to say it that way? You want to think of it that way? That's fine. It's your opinion, as long as your opinion is based on the numbers. That's all that counts. So, last one. In your opinion, which measure of central tendency is the most appropriate to use in this situation? I wouldn't tend to use the average. The average makes them look almost the same. In fact, both of those averages, if you round them off, 5.3 and 4.8, round them off, you're basically saying they both got a 5. They didn't. So I wouldn't use the average. I'd think either the median, if I had to pick, it'd be the median or maybe the mode. So, median, because it is the middle score. Forgot to do the median for the second guy, but that's okay. We could quickly do that. We'll do it in a second. Mode represents the score per hole. Okay, I'm going to very quickly do this guy's mode actually. 4 4s. I mean his median. 5 5s. And a couple of 3 5s, couple of 6s. So his median is a 5, the other guy's median is a 4. So the median also does a better job of excluding the 15 that the other guy messed up on. But again, that can be a matter of opinion. Maybe you think that hole should count against him because he did mess up. But if you're looking at, take a goaltender in hockey. He allows some soft goals at the end of the game. That's not something that he's usually going to do. So if you're looking at whether a goaltender is going to win his next game, or maybe a game a week from now, that's probably not something you're going to look at, because that's not something that he usually does. And if you're looking for a real number of what this goaltender can do or what this golfer can do, probably not a good idea to look at the areas where they messed up, unless he's been or she's been on a really bad streak and messing up consistently. Then that's another matter. Okay? So you just, again, there's different answers you can give with this kind of stuff, but as long as you're looking at it and your opinion is based on the numbers. With that, when I get to our hand-in assignment, this is based on the last 2 lessons, trend mean, weighted mean, and then the disadvantages of various of the 5 measures of central tendency. So, hand-in assignment, page 61. I'm going to do the whole assignment to 66. And this is worth how much? 46 marks. Now, you will be getting this recording on Monday, and I won't put any other classes up for this week until the end of the week, like Thursday or maybe even Friday morning is when I'm going to put the next one up. There is only one concept remaining in this unit, so we're not going to do 3 classes this week. Like I said, I'll put the next one up either Thursday or even Friday morning. All right, So let's go over that assignment then. Beginning on page 61. Here they're just asking you to calculate mean, median, and mode of the following marks. Okay, number one. And then how many students were lower than the mean, how many were higher. Same thing with the mode. Same thing with mean, and then they're asking you to do how does your score relate to the mean, median, and mode of the class? Okay, so what is the average? Like, how does the average mark that you got, how does that relate to the mean, median, and mode of the class? And then which measure of central tendency best describes the typical mark on this test? So this is very similar to that, the first example that we actually did today. What was that? Number one on page 57. It's very similar to that one. 62. We got 20% assignments, 10% participation, and then 15, 15, 15, 25 in the final exam. You take each of her marks and you do a weighting for them. So 76 times 0.20, 68 times 0.10, and so on. You get all those. Once you've multiplied all those by their decimal, you add up all your answers, and there is your weighted mean. Second part of the question, the teacher is annoyed at the low level of class participation and knocks it up to 40%. So now you've got a change. So now you have to take 76 times 0.05, 68 times 0.40, 78 times 0.10, and so on, because the teacher changed the weighting categories on them. See? Find her mark with the new weightings the way they are. Her mark will change. Does she have a reason to complain about her mark? Well, that'll be a matter of opinion, as I was saying earlier. Whatever your opinion is of that, just make sure you're backing it up with the numbers. She should have just participated more, that's my opinion. She wanted a better mark. 3. Here we're finding a bunch of gymnasts, Vanessa, Hannah, and Kwari. We're finding the median and the mode of each gymnast's scores. Okay? Do that first. The first and last scores for each gymnast are for the balance beam event, which is weighted more heavily in this competition. Calculate the weighted mean for each gymnast when the balance beam event is double the weight of every other event. So the first and last scores are balance beam, 9.4 and 9.2. You're going to put more of a weight on those. You're going to have them at double the weight of every other event. So they count for more than all the other ones do. So here's what you do. I'm going to do it for Vanessa to make sure you know what you're doing. So here she's got the balance beam 9.4 and 9.2, then she has the average of all the other ones. All right? So let's do the average of all the other ones first. (9.2) add 9, add 8.7, add 9.2, add 9.1, add 9.4, add 8.8, add 9.1. 72.5 divided by 8. So her average is 9.06, 9.1. Okay? Now we want the average of the two balance beams, 9.4 and 9.2. $18.6. Divide that by 2, that would be 9.3. Now, I want to give this a heavier weighting than the 9.1. And I think I can already see that you're gonna, when you're doing this question, you're either gonna write a lot smaller than I just did, or maybe you might need to include an extra sheet of paper to finish it. So, I've only done one gymnast here, and I'm still not quite finished. So, this should be weighted twice as much as this. So, we could do something like double the weight every other event. So if I look up here, if we just did the mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would mean each of these had a weight of 10%, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we want to double those. So if those were 10%, so we could make this 9.3, we could make this 40% and all the rest 60. So that way both of this is only 2 scores. Those 2 scores are 20% each. The remaining 80% is divided up by the other 8 scores. That means they only get 10% each. So if I do a 60-40 split, that will work. So 9.1 times 0.60 and 9.3 times 0.40, because this is only 2 scores, so they each get 20%. This is 8 scores, and they get 60. So 60 divide 8, they only get 7.5% each, and these get 20. So we're definitely doubling it up, and then some. 9.1 times 0.6 is 5.46. 9.3 times 0.4 is 3.72. So you could see how doing really well on these events would give you a real boost. So 8, 11, carry the 1, 9. 9.18. So I decided to do one of those so that you would know how to do the rest. So that's for Hannah, or for Vanessa. You still got Hannah and Kiori to do the same thing with, basically. First thing to last, essentially. Okay, 64. Then we're asking who would win. So the last thing was a weighted mean. Who would win if they did it by the weighted mean? Who had the highest score there? Who had the highest median? And who had the highest mode? These are easy marks. Just go to the information that you've already got and fill it in for part C. Part D. Consider possible arguments the losing gymnasts in C could make to argue that they should have won. Be sure to use the disadvantages of the measures of central tendency in your answer. State the arguments if the winner is determined by weighted mean. So what could the other competitor say if the winner was determined by weighted mean? In other words, if most of the marks came from the, what was it again? The balance beam. What could they have to say about that? The fact that more marks, more weighting was given to the balance beam. What could they say about that? Maybe all the other stuff is important too. What's the big deal about this? The winner is determined by the mode. In other words, who's got the highest mode? What argument could the others make about that? Well, hope they can make a good one, because that would be a pretty poor way of determining a winner. by the mode in this case. 65. State one disadvantage of each of the following measures of central tendency. Include an example that represents the disadvantage. Go back to the information that you read that we looked at during today's lesson. Maybe I can even give you the page numbers, save you a bit of time there. You will find all this on pages 50 to 53. So let's label that. So you're finding mode, median, and mean. What are their state a disadvantage of this and include an example. 66, simply do the same thing for the trimmed mean and the weighted mean. Okay, that's that. Hopefully that weighting question isn't too difficult. Number 3. If it is, you can give me a call. You can ask in person when you're at school for a few minutes or whatever. But hopefully it doesn't give you too many fits. Number 3. Hopefully the one example that I did is clear enough for you. Okay, that is that. We are done with today's lesson. So let's shut this thing off. Adios.